Hey, what's up? Welcome to AlgoYogi. Next problem in 2 pointers is arrange array elements by sign. So let's go to LeetCode and read the problem. So you are given a zero indexed array, integer array, nums of even length consisting of an equal number of positive and negative integers. You should return the array of nums such that the array follows the given conditions. So these are the three conditions. Let's read them out. Every consecutive pair of integers have opposite signs. So it's like they are basically these positive and negative integers which are equal in number, and given that our array is always even, so they're easily arrangeable, right? Like, so we have to alternate these positive and negative integers. For all integers with the same sign, the order in which they were present in nums is preserved. Okay, makes sense. The rearranged array begins with a positive integer. All right, we'll take care of that as well. I think it's a really simple problem. And return the modified array after rearranging the elements to satisfy the aforementioned conditions. It's referring to these three conditions. All right, let's get to work. So we are given okay, you know what, like I've seen like a couple of videos on YouTube, like some people when they try to teach this, they're like, oh, always approach some, like with the brute force approach. Like that's a good way. That's an awesome way. But you know what, like if you have like this really efficient solution in your mind, and that's the first one that came to your mind, I would say just go ahead with that. You don't have to like, pretend to know this brute force approach that had like big of n square time complexity and write that down and then, okay, now I'm gonna optimize it. I'm gonna optimize this solution into big of n. What the fuck is that, dude? Just move on to the efficient solution if you have that in mind. So for this problem, this particular problem, I there could be like somebody might be, I'm gonna pretend to know this brute force solution. I was like, oh, let's separate out the positive and negative integers into two arrays, and then point your pointers to the beginning of these, and then start with the positive, and then arrange them into this result array. And then that's gonna take 2 pass and all that shit. Although still you're doing basically big of n that as well, but I'm sure somebody might come up with a big of n square time complexity and be like, oh, this is the brute force solution. Dude, this particular problem, the first thing that came to my mind is like have a result array of same size, and initially in basically Python, this is how you create an array. So this would be length of nums. Okay, so I'm just gonna get rid of this bullshit from here and just write down the empty, and imagine right now it has all zeros. Okay, and now I will have my basically k pointer pointing here. So not k, you know what, I want to follow the convention. I will follow the convention. Let's have my I pointer pointing here, and then I have my I would say this p pointer pointing to the first 0 0 0 0, so, and one more 0, and this n pointer, so this is pointing to the positive index, and then this is pointing to the negative index, and every time we fill these up, then we basically move each pointer by 2. So what I mean is that you go to the first index, in nums, and then you check if this is a positive integer. It is, so move it to your positive pointer. So this will happen. So now this comes over here, this becomes 3, p is moved twice, p goes over here, so this thing is just gone. P is pointing to, just get rid of this. P is pointing here, and then you go over here, and then you're like, okay, this is also positive, so just fill it up. This is the one will come over here, and then and then this p will be pointed basically now to this over here. And here now you see negative. This time it comes to negative. Negative will be pushed over here, and this is how it's going to keep going. So this is more efficient, right? Like this takes just one pass, and then you have 2 pointers pointing to positive and negative. Whenever you're coming across any of either positive or negative, doesn't matter, they're equal in number, and they both will be basically equal to each other, and the length of the nums is even. So works perfectly. You never are going out of bound or anything. Okay, so I think this is pretty understandable, and this is what we're going to implement. We don't have to I think the best way to prepare doing these problems is just sit down and think. Take your time. Good things come with time. I understand that you might be in a hurry, you want to just prepare like 200 questions in 1 month and all that. Like, I get it. You might do it, but at the end, you might you might do that now, and then after a year you're like, oh, you know what? I have done 200, 500 problems, but I don't feel satisfied. I don't feel good enough to approach a new problem and do it. So that's why take your time. Your brain is designed to basically learn by perceiving, it takes time to basically absorb knowledge. That's what I'm trying to say. I'm not calling anybody like an idiot or anything. You can call me idiot, I don't mind, but take your time. That's what I'm trying to say. Do 2 problems in a day, but take your enough time rather than doing 10. So this is what I'm gonna do. So I'll have this result array of same length as nums, and I will have my p pointer and n pointer pointing to 0 and 1, because we were told that you want to start your array with positive integer. And then we will have this for i in range, or you know what, I think I don't even need this. I'm just gonna say for num in nums, if num is greater than 0, then I wanna add it to basically also I'm just checking the constraints. So positive and negative, 0 will never be the case. Okay, that's something you should have asked your interviewer or check it yourself. So p will take num, else and end else, res n will take the num. Okay, and increment each by basically 2, because next will be taken by the alternative one. So n will be also incremented by 2. Now once you are out of this, then the result has been completely filled, and you can return the result. So easy, right? We didn't have to pretend to come up with the brute force approach here on all that bullshit. All right, so I'm gonna zoom out and let's try to run it. I'm pretty confident that this should work. If it doesn't, then hit me. Don't hit me, because it worked. Oh, come on. Yes, 99%. Come on, baby. Yeah. Hell yeah. All right, time complexity. Oh my god, I'm so hungry. Time complexity would be big of n, because you are iterating over nums. Nums is of length n. Space complexity will be big of also n, because you are storing into result. All right, let's go to AlgoYogi and mark this problem solved. And then bye bye. See you in the next problem.